This is what we're going to do today, and probably tomorrow. Or not tomorrow, but you know what I mean. Okay. So, a permutation is an ordered arrangement of objects. A number of different, it's an, or in other words, right? Like the combination on a lock, right?
Yeah.
Or a set of lottery numbers, right? The order matters, right? Isn't it true on lottery numbers? I don't play the lottery, but don't you have to have the first number match the first number? It can't be any combination. It has to be exactly 21, 42. It has to be exactly matching. Like your third, is it? I don't know. I played the lottery once in my whole life, so I don't know. And I just like let it pick the thing for me because I happened to be in line when the jackpot was like almost $1 billion or something like that. I was stuck in line at the gas station. I just wanted to get some chips. Everybody else was getting lottery tickets, so I was like, meh, $4. Sign me up. I lost. An optimist would say I didn't win, but let's be honest, I lost. So, all right, so that's what's going on here. So we're not going to use FTI-84. Okay. This is crazy, right? So a factorial. This is called factorial. Okay, so this thing, its name is factorial. That's what it is called. So I'll say, hey, it's 6 factorial, right? So I would refer to this, I would call that, the way I would say it is 6 factorial, right? And it's interesting what it does, right, is it just multiplies. So if it's 6 factorial, it just multiplies times the number, and then the number minus 1, the number minus 1, the previous number minus 1, and it multiplies it out. It's kind of crazy stuff, right? It is, so the exclamation point is actually a mathematical operator. Okay. I'll go ahead and show you where to find that on your calculator here in just a moment. All right, so let's calculate a factorial using our TI Inspire calculator. At this point, you can just use your calculator button. So go ahead and hit this calculator button here. So we're just going to make a calculation. So we're going to hit menu. And then hit probability. And that's where factorial is. All right, so hit the factorial. I actually need to write something down to calculate a factorial. So what did they do? They did 6 factorial. Let's see. I think they got 720 in the, or what? That's what we got. Yeah, there we go. So that's where it is. So practice that. See if you can get that to calculate properly. All right. So let's see. Back over here. All right, so let's look at a permutation of n objects. All right, so the objective of, right, you guys, I don't know if you guys have ever played Sudoku, right? But the way it works is you've got, 1, 3, 9, 8, 7, 6, 4, 2, what is missing? 5, right? So in a Sudoku puzzle, right, this is already predetermined, right? Someone has already predetermined what this first line is going to be, right? And it has to be exactly in this order. So this line has the numbers 1 through 9 in a specific order. And that is why it is a permutation. All right, because it's in a certain order. Um, so if we're going to figure out how many different ways it can be filled, we're going to be looking at 9 factorial. Okay, that's how many ways. We can go to our handy dandy calculator and calculate that. I'm going to hit 9, and then I'll go menu, probability, factorial, boom. That is a lot of different combinations. Sorry, what was the number? I'm sorry. I said combinations. I don't know why I'm jumping ahead with my vocabulary. This is a permutation, right? Because order does not matter. Order does not. Sorry. Not a combination, but a permutation. Because order does not matter. Okay. Let's do it again. All right, so women's hockey teams for the 2010 Olympics are Canada, Sweden, Switzerland, Slovakia, United States, Finland, Russia, and China. Okay. So let's. How many teams are there? So we got. So how many different final standings are there? So in other words, how many different ways can we arrange 8 things, right? How many different ways can we arrange 8 things? Well, if you're being asked that, you're being asked to define what is 8 factorial. How many different ways? 40,000. Huh? 40,320. 40,320? Right. Nice. So you just put.
I knew you were gonna do that.
You just put that 8 factorial
Oh shit.
into your calculator. Cool. 8 factorial. Okay. Now it would be different if it asked us how many different ways can you arrange first, second, and third place, right? And that's what we're going to get into next. When we're talking about a permutation of n objects taken r at a time, the number of different permutations of n distinct objects taken r at a time. So for instance, right, with this team thing, we did just how many different ways can you arrange 8 different things, right? The 8 teams. But this would help us answer the question, how many different ways can you arrange these 8 teams in first, second, and third? How many different combinations of first, second, and third? Or sorry, how many different ways can you arrange? I keep saying word or combination, is not correct. But how many ways can you arrange 8 things in 3 ways? Pretty much is what this is saying, right? And we're gonna use TI expires. And I will put that up on the video. Just a moment.
Are you going tomorrow then?
I have already loaded it. So the way that I remember this is R is less than N, right? So when you're gonna put it in your calculator, it always goes N R, right? So you're always gonna put the bigger number in first and the smaller number in last. And if they're the same number, then it doesn't matter what order you put them in, right? So that's the way I remember, okay? Big number goes first, little number goes last. Let's do a little bit. Alright, so we're going to find the number of ways of forming 4-digit codes in which no digit is repeated, right? So, all 4-digit codes, right? We're not looking for a certain 4-digit code, but how do you arrange 4-digit codes? So first thing we need to know is what numbers am I picking from, right? If it's a 4-digit code, then I can pick 0 through 9, right? 0 through 9. So that means that n, my bigger number, right? N is how many different numbers I have to choose from, right?
Yeah.
And R is how many I need to arrange, okay? So I'm going to take 10 things, and I want to know how many ways can I arrange a group of 4 of them. That's what that says, okay? So I will go ahead. So what that's going to look like is it's going to be 10, the 4. So you write that. So that is going to be equal to, then we'll go to our handy dandy calculator. And now, we're going to go to the same place we were before. We're going to go menu, probability, and now we're going to choose permutation. And it gives us the NPR. And now, like I was saying, in our calculator, you're going to put the bigger number first, smaller number last, so 10. You got to put a comma. The comma's right down here. 10, comma 4, and enter. And it's 5,004. So it's really nice to have these counting methods because you would not want to make the list of all 5,040 different arrangements of these numbers, right? It would be lame, right? And you go 1, 2, 3, 4, 2, 2, 3, 4, 3, 2, 3, 4, 5, 2, 3, 4, 6, 2, 3, 4, right? It's a list like that. That's what this looks. And then you'd have to go through and now change all of the second numbers, right? And then change all of the third numbers, change all of the fourth numbers. And that would be just the 1, 2, 3, 4s. And you'd have to shift up. And you could sit there all day, right, and write all these different combinations. It's nice to have a way to count that simplifies that. So that turns out to be 5,040. So also while you're doing this, right, try to make sure you're imagining what it is we're doing, just like what I did, right? If you were to write down all the possible different ways of arranging 4-digit numbers, it would take a long time and lots of paper. Yes. I don't think it even gives the actual answer, does it? No, it doesn't. So, I mean, you could indeed put this into the formula if you wanted to, but you have a calculator. And as long as you understand what the problem is asking and what it is that you're actually counting up, I think that you're good to just use the calculator. This is what your calculator is indeed doing when it makes this calculation. Your calculator is actually substituting all those values in and then making a calculation. Yeah. Oh, that's right. You were not. Yeah. All right, let's do another one. Finding some permutations. A psychologist shows a list of 8 activities to her subject. How many ways can the subject take a first, second, and third activity? So, the total numbers of things that she gets to pick from is n, and that is 8, right? And then r is the number of ways to arrange those things, right? So r is 3. And so what we're looking at is 8p3, which turns out to be our handy dandy calculator. Will go. And hey, check it out. Here's a cool trick. You can go up. You can hit the up button till that's highlighted. Hit enter, and it copies it. That way, you don't have to push as many buttons, right? So you can go 8, 3. You get 336. So the answer, well, it's going to get, we're going to throw some probability in at the end, and it's going to get, this is going to get a little crazy. Huh? So what this is going to help us to do is find probabilities when our sample space, or even our possible, our desired outcomes, are really large. So we'll have to calculate what that sample space is before we can find out the probability. In order to calculate that sample space, we're either going to have to use a permutation or a combination. So it's going to get a little bit dicey at the end. Alright. Okay. Let's do it again. We got 43 race cars started the Daytona 500. How many ways can the cars finish first, second, and third? Which is kind of what I was talking about with the hockey teams, right? It's different, right? If we wanted to know how many ways they could be arranged, right, we could just use a factorial. Well, we want to know the arrangement of first, second, and third. So we've got our n cars is 43. Our r, the number that we're going to be arranging, is 3, right? First, second, and third. And so then we'll put that in our handy dandy calculators. We'll get 43 p3. Put that into your calculator. And I'm going to actually push the buttons this time. So I'm going to go menu, probability, permutations, and we're going to go 43, comma 3. Was it 43? Yeah, what? 3. So 74,046. Different combinations, different possible ways that we could have a first, second, and third. Alright. Good times. I'm interested in just finding out, right? So what if we were asked how many different ways can you arrange all 43 cars? Let's answer that question real quick. I would like to compare the numbers. All 43 cars we arranged. Just out of curiosity, whoops, I was about to put an exclamation point because that is going to be 43 factorial. That's how we would find out the number of different ways of arranging all 43 parts. So let's actually check that out. A great deal. A great many ways. I do not even want to say that number. I'm surprised that we didn't overflow the calculator on this. Because that's a heck of a big number. I think we came pretty close to the limits of what our calculator will do. That's a big number. So, okay, cool. Let's go. This is a technical term. All right. So, more permutations. Board of directors have 12 numbers. Numbers? Well, I'm not sure why that worked, you know. We got a president, we got a vice president, a secretary, and a treasurer. How many ways can these positions be assigned? So again, we're going to decide. On from 12 numbers, right? So n is 12, and r is the number of things we're going to arrange them into. So we got president 1, vice president 2, secretary 3, treasurer 4, so 4. So again, we're going to go 12 p 4. Calculator. We get 11,880. All right, now we're going to talk about distinguishable permutations. The formula. We are indeed going to have to use this one. Okay. Our calculator will do a lot of work for us, but we're going to have to plug in some numbers and then put that into our calculator. All right, so let's get an example of this. All right, they want to make a subdivision that has 6 one-story houses, 4 two-story houses, and 2 split-level houses. And how many distinguishable ways can the houses be arranged? Right, so that how many different ways can you? We don't want to say combination because combination implies that the order matters. In this case, the order doesn't matter. So that's why I keep saying the word combination and correcting myself, because it's really not a combination. It's just a way of arranging things. So, what in the world is a split level? The one level is split into 2 things? A house? Yeah, 2-story. Huh? 2-story. Split level is 2-story? What I'm saying, okay.
Or 3.
Oh, okay. Yeah, if you have like a basement and then that's what else, and then okay, alright, I get it. I'm from South Florida where only
You have
really
flooding if you have a basement.
yeah, you have flooding if you have a basement, and only really rich people have two-story houses because in the case of a hurricane, a two-story house does not stand a very good chance. The two-story houses will be absorbed apart.
Only the 1 story.
And also, they make all the houses are made out of cinder block. Because a wood frame house will be just leveled by hurricane. So it's much more expensive. Alright. Nothing to do with this. Here we go. So how many different ways, so let me actually so what is n? So if we're looking at this, right? What is n? Our actual n. It's our total number of different objects, right? So in this case, n is equal to the 6 one-story plus the 4 two-stories plus the 2 split level, right? Which means that n is 12, okay? We'll call it n sub 1 will be our one-story houses, so that's 6. N sub 2 will be our two-story houses, or 4. And n sub 3 is our split level houses, or 2, right? I'm going to plug all that stuff into our formula. We're going to get, okay, we're just going to get the total ways of arranging it, right? So that's going to be 12, sorry, let's memorize these are what? 12 factorial over 6 factorial times 5, right? Let's get right so it comes wrong. So we got 6 factorial times 4 factorial times 2 factorial. And we will have to actually put that exact thing into our calculator. Huh? It's to the n sub k, meaning like however many there are, right? So in this case, the last one was 3, right? But a case could be a lot of different ones, right? Yeah, we're back here. And then we're going to put this in the calculator to get to the punchline in the last 2 minutes, because I don't want to calculate this by. And you could, there's going to be a lot of stuff that will cancel out. But rather than do that, let's go. 12 factorial divided by 6. And we're going to actually put this in parentheses. 6 factorial times 4 factorial times 2 it's 13,860. Yeah. Oh.
Thanks for buying.